Hey guys, this is Vaibhav and I have a small request. If you're watching my videos and if you like my videos, then please try to subscribe my channel and press a bell icon and hit likes. It will motivate me and it will make me aware to make more videos. To create this highly knowledgeable video, I have to study a lot and then I have to put all together and create a video. Please like those videos if you found them informative. On this note, let's begin this new video. In this video, we are going to see what is virtual system load sharing. We also call it VSLS. In this video, I am going to try to simplify this topic and I hope you will be able to deliver the work related to VSLS. Let's start with the what is VSLS. VSLS stand for Virtual System Load Sharing. If you are planning to set up a VSS cluster and you wanted to have efficient balance of network traffic by distributing the load between the active virtual systems, you need to consider virtual system load sharing option for sure. So it's a definition wise is the same. So VSX cluster can efficiently balance network traffic load by distributing active virtual system between VSX cluster members. And this capacity is known as virtual system load sharing, VSLS. These virtual devices like virtual routers, virtual switch without physical or VLAN interface are not supported when we configure per virtual system state. Let me quickly make you understand about this diagram. Consider we have VSX gateway 1, this is VSX gateway 2 and this is VSX gateway 3, and we have say virtual systems. The virtual system number 4, which is at a green state, we can call it like active virtual system, and the virtual system which is at the amber state, we call it standby virtual system, and virtual system which is at gray color, we call it backup virtual system. So consider on one virtual system extension gateway, I have 3 virtual machine configured, and likewise I have 3 VSX gateway, VSX1, VSX2, VSX3, and in these 3 gateways I have also configured 3 virtual systems. Now VSX gateway 1, consider currently this gateway is active. This VSX gateway 2 is standby, and VSX gateway 3 is currently at a backup stage. Okay, so when you set up 3 VSX gateway and you wanted to have a virtual system load sharing feature amongst them, you need to have one VSX gateway always in active state, one VSX gateway always in a standby state, and one VSX gateway always at a backup state. Depending on your requirement, you can set up this sort of configuration. Now similar thing goes with your virtual systems. So the virtual systems which is at the VSX gateway 1, if you have a 3 virtual system there, you will configure one virtual system as an active one as a standby, one as a backup. But with the VSX gateway 2, you will be having the same sort of scenarios. You will have one active, one standby, one backup. Likewise, in VSX 3, you will be having the same sort of scenario, one active, one standby, one backup. I will tell you why this sort of arrangement is needed. But for now, just understand this is what the situation will occur when you configure virtual system load sharing. We will going to simplify this, but for now just understand this is the situation. And here if you see this blue link, we call it sync network. Okay, now VSX gateway, you have set up virtual system load sharing clustering. So when you do that, based on the algorithm what checkpoint have for the VSLS, depending on that algorithm, this arrangement will happen, right? One virtual system, one gateway, one virtual system become active, one become passive, one becomes backup. Whenever the failover occurs, what happens? Consider this VSX gateway goes down, the load will get transferred to the next available standby member. Consider in this case this is the next available standby member. It will become active, right? This is down, and now this was a earlier backup VSX gateway that will become standby. In the event this will come up and you have set up a preemption, then this will member again become active and this member will goes to the standby and this guy goes to the backup, depending on your configuration. This is what happens with when we fail over between the VSX gateway. In the event of virtual systems, so these are the virtual systems, if those get fail, consider this was active on gateway 1, so this gateway 1, this virtual system is active, currently this gateway is active, right? If in case this virtual system get fail, then what will happen? The failover occur and next available active machine from the next gateway will take a preference and that will become active. Now let's understand key points. Number 1, a different member host active peer for each virtual system. What that means, as you can see, at the same time VSX gateway 1 and VSX gateway 2 and VSX gateway 3 can host active member, but the load distribution happens depending on the algorithm what is there. This distribution spared the load equally between the VSX cluster members. What that means, depending on the weight to each virtual system, depending on that weight, the load of the traffic will take place. Consider you have say 30% traffic passing from this VSX virtual system, 60% traffic is passing from this VSX machine, virtual system machine, and then 10% traffic is passing from this virtual system of VSX gateway. This setting you can do by manually changing all this thing, but when we set up a virtual system load sharing, by default equal load distribution happens. So every machine here will take load as per the algorithm setup. So consider one virtual system will take 30%, second will take 30%, and third one will take 40% because 10% is remaining. But equal load distribution, the checkpoint will try to do equal load distribution amongst these virtual systems. That it means about the virtual system load sharing. The load is shared amongst them equally. That is the first key important point. Now, when you create a virtual system, VSX automatically assign standby and backup states to the applicable peer and distribute them between the other VSX cluster members. So when, as I said, when you set up this VSX gateway, and among them if you enable virtual system load sharing algorithm, based on the algorithm what the checkpoint have, depending on that, it automatically assigns the states. So it will make one VSX gateway active, one as a standby, and one as a backup. This is for the VSX gateway, and depending on the virtual systems how many you configure, similar things happens with them also. So one become backup out of the one VSX gateway I'm talking about, one become active, one become standby. Similar thing goes to the VSX gateway 2 for the virtual systems and the VSX gateway 1 virtual systems. So next point, in the event that a VSX cluster member fail, VSLS direct traffic destined to affected virtual system to their fully synchronized standby peers, which then become active. At the same time, a backup virtual system switches to standby and synchronize with the newly active virtual systems. What that means in two scenarios. Number one scenario, consider this VSX gateway got failed. It will transfer the complete load of the traffic to the next standby member which is fully synchronized. In this case, consider this member is fully synchronized, so the load will transfer to this member, and if in case this also member is synchronized, then the load will distribute amongst this member as well. But in the case this member is not that full synchronized, the load will only transfer to this VSX gateway. Similarly, if the virtual system get failed due to one or the another reason, this virtual system which was active, the next member which is fully synchronized with this virtual system, so consider this one, it become active. So this virtual machine get active, and the next available virtual machine which was acting like a backup, that become a standby. And likewise the other arrangement also happen, like the backup virtual machine changed their state to standby, and the standby virtual machines change their state to the active. It's depending on the what the virtual system priority we have set, and depending on the what algorithms the virtual system load sharing, sharing amongst them, depending on the virtual system extension VSX gateways availability. Next point, in the event that an individual active virtual system fails, it immediately fail over to the standby peer, and one of its backup peer become the standby, synchronizing with the newly active peer. So this failed, then the next standby member become active, provided that standby member is fully synchronized, and the next backup member which was acting as a backup will become a standby, depending on the algorithm what we have set, or depending on the algorithm that what checkpoint have for the VSLS. And the last important point is VSLS lets administrator manually assign virtual system to specified VSX cluster member, or let VSX automatically assign virtual system traffic dynamically. So depending on the administrator's choice, it can set these virtual systems priorities as per his requirement, or we, as per the checkpoint algorithm, if you don't do the manual configuration there, it will automatically do the virtual system traffic configuration. So now let's talk about virtual system priority. Virtual system priority refers to the preference regarding which VSX cluster members host a virtual system's active, standby, and backup states. This preference is expressed as an integer value. So consider you need to set up a virtual system with the preference when they become active, when they become a standby, when they become a backup. So that preference you can set up using the virtual system priorities. So 0 priority is nothing but the highest priority. So I can write here the 0 is the highest priority, which indicates the cluster designated to the host virtual system is active state. So in this diagram, consider I have a gateway 150, and in the 150 gateway I have the VSX1 and the VSX5 at 0 priority. That means this virtual system cluster is designated host VS1 and VS5 have the highest priority, and they are at the active state, and the priority with integer 1 is nothing but the second highest priority, which indicating the member designated to the host virtual system is standby. So this is the second highest priority, and whosoever having this priority, so consider VS3 is having this priority from the gateway 150, those are at the standby state, and whatever the priority we will see is greater than 1, we consider that priority as the lower priority. Say consider 2, this is nothing but a lower priority, which indicate the VSX cluster member designated to the host virtual system is at the backup stage. So this VSX2 is at the backup state. Similarly, if you see the other virtual system extension gateways, you will see these priorities, and depending on that you will understand at which gateway which virtual system is acting as a active and the traffic is processing from them. So here if you see number 4, number 6, here like on the gateway 150, those are the active one. In gateway 151, the VSX gateway 151, virtual system 2 is active. In gateway 152, virtual system 3 and 5 is active, right? So the VSX cluster member assigned priority 2 is the first to switch to the virtual system to the standby state in the event of failure, either active or standby virtual systems. So whenever one of the VSX gateway get failed, whatever the virtual system having the priority 2, they become standby. they not become active, they become a standby, and whosoever having the priority 1, they become active. Likewise, the algorithm switches and the priorities get assigned, and in that way you will get the load distribution and sharing features amongst them. And you can use VSX underscore util VSLS command to see all those things from the command line, what we have just discussed about the priority. So this is very crucial and important command. In the lab, I am going to show you this command, but for the understanding, the command VSX underscore util VSLS is the command which we need to run to see all these things. And the last important point here is the wait. So whenever you create a virtual system with the help of the checkpoint virtual system algorithms, this wait is automatically assigned to the virtual systems. So by default, checkpoint assign wait 10 to each and every virtual system what we have configured. But when you want to have any particular virtual machine get higher weight and do more load of the traffic, to handle more load of traffic, allows you to assign weight to individual virtual systems. So this weight which you are seeing now 10 10 10, you can modify them depending on your requirements. So when you assign a heavier weight to a virtual system, it will gives you a large share of resource on a specific VSX cluster members, and other virtual systems having the less load, maybe sometimes due to the failover scenarios, things hampers. So basically we gives by default weight what what the checkpoint algorithm assigns, and this changes in weight you can also deliver with the command VSX underscore util VSLS. VSX cluster member failure scenario. In this scenario, VSX cluster member 1 fails and its active and standby virtual system fail over to the VSX cluster member 2 and VSX cluster member 3. The active virtual system VS1 moves to the cluster member 2, VSX cluster member 2, and direct all VS1 traffic itself. Its backup peer on VSX cluster member 3 synchronize with the new active virtual system and become a standby. VSX2 on VSX cluster member 2 become the standby and synchronize with the active peer on the VSX cluster member 3. For VS3, the active and standby peer remains the same. And similarly, consider this gateway is active but one of the virtual system get failed. What will happen in a failure scenario where an active virtual system fails on one member but the standby and the backup virtual system remain up? The active virtual system fail over to its standby peer and its backup become the standby. The new standby synchronize with the new active members. So this is what happens when the failure occurs.